Hello, so in this video I'm going to talk about this power shield that I made. It's a custom Arduino shield, so it fits on top of the Arduino just like that, and so any connections made onto this board here will obviously make connections to the Arduino itself. Alright, and so what this does, this board will, it allows lots of different options for how you power the Arduino. And so this is a bit of a layout of the circuitry on this board. It's quite confusing because there's a lot of different options. There's a lot of male header pins here, and that will allow you to attach jumpers to then make different connections to make different options. So I thought in this video I'll just go through some of the circuitry in here to maybe explain some of this confusing arrangement here. So you'll see there's a button here, and that's this button here. And so with this button, you could have the Arduino plugged into this board, having power either through the screw terminals or through the micro USB port, okay, here, or screw terminals. And then there would be no power to the Arduino until you press this button, and then it powers on. Okay, so let me show you how I did that. So I thought the easiest way would be to just demonstrate some of the circuitry on this breadboard. So there's this push button. There's a couple of diodes here, and then a P channel MOSFET and an N channel MOSFET. Okay, and then some resistors, 100 ohm, 10,000 ohms, 10 kilo ohms, and 47 kilo ohms. Okay, so let me just show that. So first I have a button. Okay, so let me connect that. So buttons, these two pins are connected, and then on the other side these two pins are connected. So let me just bridge the gap on the breadboard there. And then so that button is actually connected to ground, so let's do that. So let me connect this side here to ground. Okay, so now these two sides are connected to ground. If I press this button, then whatever's on this side will be connected to ground. And so next to that, I have this is a P channel MOSFET. So this is supposed to be that MOSFET there. This is what I had. This is an IRF 9630. I don't know if you can read that, but it has a gate pin, a drain, and a source. So let's put that next to our button. Okay, so gate, drain, source, and it's connected to the button through this diode here. I used a Schottky diode in my actual shield, but I think this one is just a rectifier diode. So here's the stripe here, right? So that's the cathode, and so that connects to the button, and the anode side connects to the gate. The drain pin in the middle, that's where we're going to get power out. So that's going to power our Arduino. I'll just leave that for now. And then the source pin is connected also to positive voltage, right? So the red here, I'm going to connect to my positive voltage of my battery. So there. Okay, so the only thing missing is, well, let's put that in. Let's put the power in here. So in the middle pin, our drain pin. So for example, let me just, so this would be, let's say, on the board. Let me just show you. Oh, I am missing this resistor here. So 47 kilo ohms. I think this is 47 there, or this is maybe 40,000 or 47,000. It's pretty close. So that goes also to the gate, to the positive voltage. So this is a pull-up resistor. So with this in, when we connect our, let me put it closer. So there, it's right next to the gate. Or sorry, right next to the diode, which is also connected to the gate. So when we power up the breadboard, there's nothing connected to it power-wise. That will pull this gate of this P channel MOSFET high, so it'll be off, so no current will flow through it. So now if I connect the ground rail to the ground of my Arduino, and then I'm going to use a rechargeable 9-volt battery. So because this is 9 volts and this uses 5 volts, I'm going to connect this to V in. Okay, V in and ground. So let me just connect this battery. So ground and V in. So as I connect these, nothing happens. Okay, it's off. But when I press this button, that gate will be pulled low through this connection, and you'll see that the Arduino powers on. There's the power light, and the sketch on this chip is just flashing this LED. Okay, but if I release, it turns off, right? Because when I release, this pull up resistor pulls the gate high, and then power stops through that. Okay, so the next, let me just remove this out of the way. So the next transistor here is an N-channel MOSFET, and what this is used for is to latch this gate low, and so then that will keep it going and keep power going to my Arduino. So this is my N-channel MOSFET that I had. I don't know if you can see that, but it's FQP30N06L. Okay, so let's put that in. Let me put that in next to our other MOSFET. Okay, and so it has on its gate 2 resistors. So the 10K is a pull down to ground. So here's 10K to ground. And then there's a 100K resistor. And so this is what we're going to do to keep this on, to latch this. So here's 100 ohms. So I'm actually going to put it on the back here. So it's connected to the gate. Okay, so this resistor and this resistor are both connected to the gate. The drain of our N-channel MOSFET goes to the gate. Let's connect that. I'll connect that with this. So the drain is the middle pin going to the gate. Yep, going to the gate. So let me just move this to give some space here. It's still connected. Okay, there. Okay. So middle pin, the drain to the gate. And then here the source pin is connected to ground. Okay, so now when this gate is pulled high, it will keep a low on this MOSFET, and that'll keep power going. So let's try that again. So ground, put this on the center pin. Okay, plug in my battery. Okay, so again now, if I press this button, powers up, but if I let go, it turns off. And so how this N-channel MOSFET works is, if I connect the gate to one of these digital pins, and when it powers up, pull that digital pin high right away, that will latch this circuit and it'll keep it going. And so then the Arduino is basically powering itself. So right now I don't have anything programmed in here to do that. So let me just demonstrate by plugging it into the positive voltage. So if I power it up, give this a high signal, and let go, now it continues to power on. Okay, so this could be used for any circuitry. It doesn't have to be used just for an Arduino, but you need some way to pull this pin high, and that'll latch the circuit. Okay, and then in the Arduino programming, you can set it so that at some point, whether it's a certain time period or if a sensor reads something, you could pull that pin low, or whichever pin you used, and it would power itself off. Okay, so maybe that would be useful. Okay, maybe you're going to detect the battery voltage, and before it goes dead on its own, you power off your Arduino, and so it doesn't go through a brownout. Now, another thing you can do is on a subsequent press, you can use this to power it off. So you need some way to monitor that. So either like a digital pin, or here I have the option of using one of these analog pins as a digital pin. And basically you have to pull this button. And if this button is pulled low, then you can tell whatever this is connected to, whatever digital pin this is connected to go low, and it's a way of using this button to turn on, but then to subsequently turn it off. To do this, you need to pull up whatever pin you use as your input to sense this button as a pull up. So input pull up. So let me show you that. So let me just again move these out of the way. So, so there is another diode connected to this push button. So here I have another diode. Okay, here's the stripe, the cathode. So let's plug that in. I'll use the back again. So I just plug that in. Okay, so this is connected to the push button. Okay, same as that diode. Nothing is connected to it. This is not connected to it directly. Now, in the programming, like I said, I would do a pull-up, input pull-up. But for the sake of the breadboard, I'm just going to use a pull-up resistor. So this is just a 10K. It's not on here because I used the input pull-up, whatever pin I use. But you need to pull up this side of the transistor. So let's plug that into the positive rail. Okay, and then you have to connect. So where the pull up, where this side of the diode is, would be this pin here. Okay, so now, like, obviously I don't have the program on here, but if I show you, here's my multimeter. Okay, it's on DC voltage. So here, let's do this. So I need to connect ground. Let me just connect ground. So I have a reference. Let me just put that out of the way. Up here. This breadboard is a little bit hard to use. There we go. Okay, and so then this is my wire connected to the button. Okay, so let's do that. So so you'll see actually right now the battery is connected. So it's about 9 volts because that's what this is powering. So if you used an input pull up and connected this to some input pull up here, it would be 5 volts. But right now, because we're using the power rail to pull up our voltage, it's about 9 volts. So again, in the Arduino programming, if you, let's plug it back in. Okay, so in our programming, if I turn it on and whatever I have connected to this N-channel MOSFET latch it, that would keep it going, right? Yeah, it's going. And you would need to declare some pin as an input pull-up to monitor that button. But if you press that button now, it'll connect through the diode to ground because of the button. There, that's less than 1 volt, right? That's in millivolts. Oh, sorry, that's, yeah. it's 6.6 volts. Okay, so less than 1 volt. So that would be a digital low for the Arduino. And you can use that then to, in the programming, to tell them this pin here to go low, and that would shut off power, right? So that's how you would set up a push button on, push button off. Okay.